Hi, this is Olajide from CTF Security and welcome to another video on investigating window event logs. In this video, we will carry on with our investigation on the Tempest Tryhackme machine. If you haven't seen the first episode yet, it is recommended you watch episode 1 before carrying on with this video. You can simply click on the link at the top right corner of this video, or rather go to the description box below where you find the link to the episode 1 and other relevant information regarding this video. Now that we're on the same page, let's investigate Tempest. So in this video, we're going to be working locally. So I have extracted our audit trails from the previous video into our local machine. You can find the audit trails right here with the name incident files. And on the audit trails, we have the capture.pcap.ng, we have the sysmon.csv, sysmon.evtx, sysmon.xml, and windows.evtx. We also have some tools we use from the previous video, the likes of the EVTX, ECMD, the Sysmonview, and the Timeline Explorer. Additionally, I have installed the Brim application, which we are going to use for further analysis on our captured data. So let's head to the Tryhackme question, and we have on the chapter 5, which is initial access stage 2 execution. So it reads malicious document stage 2. Based on the initial findings, we discovered that there is stage 2 execution. The document has successfully executed an encoded base64 command. Decoding these strings reveal the exact command chain executed by the malicious document. So what we're going to do right now is to find the encoded base64 command, which we have done from the previous video. Then we can build upon that by decoding this base64 string to reveal the exact command chain executed by the malicious document. So what we are going to do now is to fire up our Timeline Explorer. Okay, so I have the Timeline Explorer on the desktop inside the tools folder, and I can just fire that up right here. Open. So we just give that about 1 minute to fully load. Okay, so we're going to the file menu, open, and we're going to load our artifacts into the Timeline Explorer. So we're loading the CSV file format. So just click open. Loading file. Okay, great. So from the Timeline Explorer here, we can look for the CVE vulnerability, which is the msdt.exe. Nice. And we would trace the one that has to do with the event ID 1, which is associated with file create. And if we go to the execution information, all right, we get our base64 data. So I'm just going to grab this base64 string, then we can decode this string using the cyberchef. So we're using the cyberchef github.io link. Okay, we paste our base64 string right here and we can use this tool right here to decode our data from base 64. We have the output of our base 64 command, which has to do with changing directory into this startup directory in the app data. We also have the invoke web request, downloading a particular file called update.zip from fishstream.xyz, giving it a specific name called update.zip, using the expand archive to unzip this file, and we also have giving it a destination folder which has to do with this current directory here. And lastly, we have removing this file from that specific directory. So what we can do is go back to the question, which says the malicious execution of the payload wrote a file on the system. What is the full target path of the payload? Now, before we get to the first question, there are a few things we need to keep at the back of our mind. One is the autostart execution reflects explorer.exe as its parent process ID. Child process of explorer.exe within the event time frame could be significant. And lastly, process creation event 1 and file creation event 11 succeeding the document execution award checking. So we are after the child process of explorer.exe, and we should also take note of the event 1 and the event 11, and of course we should focus on the Sysmon audit trail. So now that we are able to decode our base 64 command, that there's actually a file being written with the name update.zip. So what we're going to do is head to the timeline explorer, and from the timeline explorer we can just query, beg your pardon, I'll just go back to grab that, just copy this, and we head to the timeline explorer. You can just paste this right here and we search, and if we move to check the specific ID we have here, we have the file create event ID, which is event ID 11, and if we scroll, let's scroll to payload data 4. If you scroll to payload data 4, we have our target file name, which is what we are being asked to fill in that specific question. So what we need to do is to grab this. So I'm just going to grab the full part and paste. Right here. Submit. And that was correct. So the next question says, the implanted payload executes once the user logs into the machine. What is the executed command upon a successful login of the compromised user? Now, once there is an execution of the payload, we have process created. So what we need to do is to filter based on process creation on our timeline explorer. So if I head to the timeline explorer, I'll just do away with these search terms, and I can filter by the event ID 1 that has to do with process creation. So I'll just go to the filter button, select 1, and these are the list of all the events associated with event ID 1. So what I will just do is scroll down to executable information. So now we have list of all the executable information of event right here, and we have a lot of them ranging from the msdt.exe itself, that is the Microsoft Diagnostic Troubleshooting itself. We also have some svc host. We also have some net user command right here. You can see it here, local groups, net.exe, local group administrator. So we're looking for something that is out of the ordinary. And if you look carefully, you see that we have a PowerShell right here. And the PowerShell has to do with the invoke web request to this domain fishstream.xyz, and then downloading a file called SPF. But we are not sure if this is the specific process that gets created, command that gets executed. So what we can do is to correlate this with the information we have on this tax 5 that says child process of explorer.exe within the event time frame could be significant. So what we'll do right now is to cross-reference this with the child process, or parent process rather. So I'll just head to the parent process column, and you can see that we have the parent command line right here. So you can see that we have the explorer right here and the explorer here. So let's scroll down. Okay, I think we just have two explorer. So if we go back to the executable information, we have let's see the PowerShell once again. All right, so I can just search the list of PowerShell command right here. Okay, we have some few PowerShell command here. So what we'll do now is to check which one has the parent process of explorer.exe, and if we trace that, we can see that we have this first one having a parent command line of explorer.exe. So what we'll just do is copy this executable information so we can do away with the code. Full part. So copy, then I can paste it right here. Okay, that was correct. Based on the Sysmon logs, what is the SHA-256 hash of the malicious binary downloaded for the stage 2 execution? So let's take a look at our stage 2 command. So if we move to the timeline explorer from our previous solution, which has to do with the PowerShell command, the PowerShell command was used along with the sat-util to download a file from the fishstream.xyz domain, which the file name is first.exe, and was downloaded to this destination, the c/users/public/download/first.exe, and later was executed on the target machine. So we're looking for this particular file called first.exe with this specific file path. So I'm just going to head to the timeline explorer, and we are searching for the file first.exe. So we have some couple of first.exe, but we are after the one inside the c/user/public/download/first, which is this one. So what I'll do is just trace this back to where we have our hashing value, and that is on the payload data 3. So on the payload data 3, I'm just going to double click on this, and we're going to grab our SHA-256 hash value, which stops here. Copy, and we paste right here, submit, and that was correct. So next we move to the next question. The stage 2 payload downloaded established a connection to a C2 server. What is the domain and the port used by the attacker? So what this is saying is our first.exe established a connection to a remote domain. What is this domain name and what port is being used for this communication? So we can easily solve these tasks using the Sysmonview. So what I'm just going to do is fire up our Sysmonview. So we can just go back. So open the Sysmonview and let's run Sysmonview. So this will take a couple of minutes. All right. So what I'm going to do is go to the file. We're going to load our Sysmon event logs. And we're pointing this to the incident file. And inside the incident file, we're using the sysmon.xml file. So we open, so import. So we have 2,559 events imported. So we're just going to acknowledge this. And we're searching for the first.exe. So I'm just going to click on that. We'll click on the image part and the session GUID. So we are going to get all the summary of event associated with this file first.exe. And the first thing we have is a DNS query that is being resolved to resolve cyber.xyz. And based on the network connection, this was using a source IP 192.168.254.107 with a destination IP of 167.71.222 running on the port 80. So what we are going to do is just to grab this query name resolve cyber, copy, and we head to our Tryhackme room. We paste this and we specify the port number, which is port 80. Submit. All right, so we head to task 6. Based on the collected findings, we discovered that the attacker fetched the stage 2 payload remotely, that is through the resolve cyber.xyz. We discovered that the domain and IP invoked by the malicious document on the Sysmon logs. And we also have, there's another domain and IP used by the stage 2 payload logged from the same data source. And we have some couple of things we should note. We can now use Brim and Wireshark to investigate the packet capture, find network event related to the harvested domain and IP addresses. Sample Brim filters that you can use for the investigation is right here. So we also have our data source to be packet capture, which is our capture.pcap.ng. So in order to solve these tasks, what we need to do is to fire up our Brim, and I've done that right here. So what next is to load our artifact into the local lake. So I'm just going to click on choose file, and we're going to select our capture.pcap.ng and click on the open. So this is going to take some minutes, waiting for pool to become queryable. So now we've successfully loaded our capture.pcap.ng into our local lake. So what we're going to do next is to filter these queries based on HTTP requests. So I'm just going to click right here, and this gives us all the available HTTP requests. And from here, you can see various methods used in connection, the get request. We also have posts, and of course, we have the head also as a method. And if we head to the question, and it says, what is the URL of the malicious payload embedded in the document? Now, what document are we talking about? That is our initial Word document that was executed in the first place. And we know that this Word document communicated with the fish team.xyz. So what we are going to do on the Brim is to narrow this query down using the fish team.xyz, and we execute, I beg your pardon, xyz. All right, so we have all the available connection to the fish team xyz right here, and we have some that has to do with the get method and the head method, and of course we know that this is not associated with the final.exe or the spf or the ch.exe. So we are after a URL. We have the URL that is being associated with the get method, which happens to be the index.html. So I'm just going to be trying this out. So I'll double click on this and I'll wait for the Brim log detail. Okay, so I can copy the URI from here. Beg your pardon. So I'm just going to see what they want. So we can have the answer pasted right here, and we have the http fish team.xyz, and let's paste that. All right, that's correct. So we have our next question to be, what is the encoding used by the attacker on the C2 connection? So when we're talking about the C2 connection, this has to do with the connection with the resolve cyber.xyz, which is the remote domain. So we can go to the Brim and filter by resolve cyber. Did I spell that correctly? .xyz, or I can just head to the Sysmonview to copy that. Okay, so search. We have all the connection to the resolve cyber.xyz host. We can see that this URI has to do with a very long string right here. So I'm just going to be opening one of the string, and let's wait for the Brim log detail. Okay, so you can see this actually looks like an encoding. So I'm just going to copy this. Let's head to CyberChef in order to find out what kind of encoding we have right here. So I'm just going to be replacing this input to remove the recipe. So we are pasting it right here, and we are removing everything that has to do with the URI and the parameter right here, and let's decode this. You can see this is decoded to a base 64, and it has to do with net group, local administrator, members, and these are all the members on this particular machine. So we can say that from the question here, which says, what is the encoding used by the attacker on the C2 connection? So every command executed by the attacker is being sent through a base 64 encoding, and you can see the list of all the command. And we can take a look at the second command that was executed, and let's see the URI. I'll just double click on that once more. Wait for the Brim log details. So we can grab this, head to cyberchef, and we can paste this right here. And just like before, we remove the URI, and we can see that this was also encrypted using a base 64 encoding. So we just head to the Tryhackme rule, and this is base 64. Submit, and that was correct. And the next question says the malicious C2 binary sent a payload using a parameter that contained the executed command result. What is the parameter used by the binary? So when we have communication between the remote machine and our target machine via the command and control, if you go to the Brim, you can see that we have our parameter here to be q equals to the string of our base 64. So our parameter for this question is q. So I'm just going to submit that, and that was correct. And the next question says the malicious C2 binary connect to a specific URL to get the command to be executed. What is the URL used by the binary? In this task, we are after the URL used by the binary, and when we go to the Brim environment, you can see that from the URI column right here, if we double click, we have the combination of our URL, the parameter, and our base 64 encoding. So what I'm just going to do is simply grab the full value for the URI, then I can head to the tags, paste this, and ensure the base 64 is removed, including the parameters. So I'll just submit, and this is correct. So we move to the next task. What is the HTTP method used by the binary? So let's once again head to the Brim. You can see that all the HTTP requests used for the resolve sidebar happens to be the get method. So I'm just going to head to the Tryhackme and fill in get method. So get method was used by the binary. So the next question says, based on the user agent, what programming language was used by the attacker to compile the binary? And we have a format for our answer. So these tasks cannot be solved on the Brim, so we're just going to head to Wireshark. And from the Wireshark environment, I'm just going to go to File, Open, and make sure I specify the capture.pcapng. So click on the Open, and we wait for this data packet to be loaded into the Wireshark environment. So now that the data has been fully loaded, we're going to filter by HTTP request. Sorry about that. HTTP request. And from the HTTP request, we are after the base 64 request. So I'm just going to scroll through to where we have base 64 request. Just bring this down a little bit. Base 64. All right, so we have one base 64 right here. So I will just click on it, and I can go to the hypertext transfer protocol right here, and we can see more information about this particular request that has to do with resolve cyber.xyz on the port 8080. We also have the types of connection, which is keep alive, and we have a user agent called name HTTP client. NIM is a programming language, a multi-programming language that offers powerful customization option with the ability to compile to everything ranging from C to JavaScript and other various programming language. So what we are going to be doing is just picking the word name, and we head to our Tryhackme, and of course in lowercase we use the word name and submit, and that was correct. And this marks the end of this video. Please do ensure you check back on this channel for the next part of this video, where we will cover task 7 to task 9. Thanks for watching. If you like or learned something new, please ensure you like, share and leave a comment. And if you're not already a subscriber, please hit the subscribe button down below to join our community and get exclusive benefits. Your support helps creating content you love. Thank you for your help, and I'll see you in the next video.